Lesson 4.4, Counting. Example 1. When ordering a certain type of computer, there are 3 choices of hard drive, 4 choices for the amount of memory, 2 choices of video card, and 3 choices of monitor. In how many ways can a computer be ordered? Alright, if we apply our fundamental counting principle, then all we need to do is multiply the total number of each of these different options, and that should tell us how many computers there are altogether. So let's see, we have 3 types of hard drive, and then we have 4 types of memory. We have 2 types of video card, and then we have 3 choices of monitor. And when we multiply all those together, we get 72 different types of computers. Example 2. A quiz consists of 3 true-false questions and 2 multiple-choice questions with 5 choices each. How many different sets of answers are there? Alright, now in this case, we have actually 5 questions on the test, and so there are 5 sets of options that we're going to have to multiply together. Okay? Now the first question is true-false, and there are in fact 2 different ways to answer a true-false question. Question number 2 is also a true-false question, so there are 2 ways to answer that. Question number 3 is also a true-false question, so there are 2 ways to answer that. And then we get to question number 4. This is where the multiple choice starts. There are 5 ways to answer that one, and then the last question, number 5, there's also 5 ways to answer that one as well. So when we multiply 8 times 25, it turns out there are 200 different sets of answers to this particular quiz. Example 3. A committee of 8 people must choose a president, a vice president, and a secretary. In how many ways can this be done? Alright, this is going to be a permutation, and we have 8 in our sample here altogether, and we're supposed to choose 3 of them. So this is going to be a permutation of 8 things taken 3 at a time. And if we put this into our formula, that means we're going to have 8 factorial divided by 8 minus 3 factorial. Now remember, the exclamation point just means that you're multiplying that number times every other integer that is less than itself there, all the way back to 1. So this is going to be 8 factorial divided by 5 factorial. And that means 8 factorial is actually 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 5 factorial is going to be 5 times 4 times 3 times 2 times 1. And then we'll cancel what we can. We can cancel the 5s, the 4s, the 3s, the 2s, and the 1s. So what we're actually left with is going to be 8 times 7 times 6. And then we'll put that into our calculator. And that will give us a grand total of 336. So there are 336 ways to arrange 8 committee members into sets of a president, vice president, and a secretary. Alright, example 4. 2 of the committee members are Ellen and Jose. Assume the assignments are made at random. A. What is the probability that Jose is president and Ellen is vice president? Alright, now keep in mind we had 8 committee members to try and figure out who's going to get which position for. And now we are sitting 2 of these people into those positions. And so what that means now is that I only have 6 committee members because 2 of them have already been assigned a position. Okay. not only do I only have 6 committee members to assign a position to, but now there's only one position that needs to be filled, and that's going to be the one for secretary. And so that means that for A, we have 6 people. We're going to do a permutation, and we're going to choose them one at a time, and this is going to give me 6. Alright, so if we are looking for the probability for Jose to be president and for Ellen to be vice president, then that's going to be 6 out of, and remember, we'd already done on the previous page the total number of ways to arrange these people. That was 336. So it's 6 out of 336. Right? And then the 3 decimal approximation for that is 0.018. Alright, B. What is the probability that either Ellen or Jose is president and the other is vice president? Alright, so in this case, we're going to have to place either Ellen or Jose in the position of the president first, and then we'll be able to go back and pick the secretary. And remember, whoever doesn't get president is going to be the one that gets to be the vice president. Alright, so the first thing we're going to have to do is we're going to do a permutation of 2 things, taking one at a time. In other words, I'm choosing between Ellen and Jose to see who it is that's going to get to be a president. And this is going to give me 2. And then we already knew that the permutation of 6 things taken one at a time, this was to choose the secretary, was going to be 6. Okay? Alright, so now the number of ways to choose with either Ellen or Jose as president is going to be 2 times 6, or 12. Right? And so now we can go and we can answer the question that we were asked, and that question was, what's the probability? So we are actually looking for the probability that Ellen or Jose is the president. This is going to be 12 out of 336. And when we get our decimal approximation out of the calculator, it gives us 0.036. Example 5. 8 college students have applied for internships at a local firm. 3 of them will be selected for interviews. In how many ways can this be done? This is going to be a combination because we only know we want to pick 3 people. We aren't actually giving them any kind of an order. You're going to go first, you're going to go second, you're going to go third. So because there's no order involved here, this one's going to be a combination. So what we're going to be doing is we have 8 people. We're going to do a combination, picking 3 of them at the time. Right? And if we do this with the formula, we're going to have 8 factorial on the top, and on the bottom we're going to have 3 factorial, and this is going to be multiplied by 8 minus 3 factorial. Right? So this is going to give me 8 factorial on the top times 3 factorial times 5 factorial. Alright, so we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, 3 factorial is just going to be 3 times 2 times 1. And 5 factorial is going to be 5 times 4 times 3 times 2 times 1. Alright? And the 5s will cancel, the 4s will cancel, the 3s will cancel, the 2s will cancel, the 1s will cancel. And over here, 3 times 2 is 6, so that'll cancel with my 6 right there. So it looks like the number of ways this can be done is 8 times 7, which is just 56. Example 6. 4 of the 8 students are from Macon State College. What is the probability that all 3 of the interviewed students are from Macon State College? Alright, so the first thing we want to do is we want to pick those 3 students who are actually going to get an interview, and they need to come from Macon State College. Now, 4 people come from Macon State College, but we only need 3 of them. And so we're going to start this off by doing a combination of 4 people chosen 3 at the time. Now if we do this with our formula, this is going to be 4 factorial divided by 3 factorial times 4 minus 3 factorial. Alright, so this is going to be 4 factorial over 3 factorial times 1 factorial. So we've got 4 times 3 times 2 times 1 over 3 times 2 times 1 times 1. And now we cancel out what we can. And so it looks like there are 4 different ways to choose the persons from Macon State College who get an interview. Now to answer our question, what's the probability? Well, remember there's 56 total ways we can choose 3 people from all 8 of them. Alright, so the probability of 3 Macon State College interviews will be 4 out of 56, the total number of interviews we could have. And then when we put that in the calculator for a 3 decimal approximation, number 5, there we go, we get 0.071.